2010 Calculus BC free response question number 1. This is a problem in which we have functions is a function that tells us a rate of change. G of t is another function that tells us a rate of change. So that's what this problem is about. Functions involving rates of change. So let's read through it and see how we do it. This is a graphing calculator problem. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by f of t, which has units of cubic feet per hour. Time is measured in hours since midnight. When you read this sentence, when you see the word rate, you know you have a function that tells you a rate of change. And you can also see that from the units. So snow is accumulating on the driveway at a rate given by f of t. Janet starts removing snow at 6 a.m. Now, look at the next sentence after that. Again, here's a key word, the rate, G of t, in cubic feet per hour. So you see the word rate, and then you see cubic feet per hour. So that tells you that you're working with another function that's also a rate of change function, at which Janet removes snow. So this is telling you the rate at which Janet is removing snow from the driveway at various times after midnight. So for the first 6 hours from 12 a.m. to 6 a.m., she's not removing snow from her driveway because, well, she's probably sleeping. And then she wakes up at 6 and she starts removing snow from her driveway at a rate of 125 cubic feet per hour. And then from 7 to 9 a.m., she's removing snow from her driveway at a slower rate of 108 cubic feet per hour. Maybe she wakes up with a lot of energy, and then after 1 hour of working, maybe she gets tired. So she's removing snow at a slower rate from 7 to 9. So we have two functions in this problem that tells us rates of change. So we're working with a problem in which we have functions that involve rates of change. And we know something about the fundamental theorem of calculus. If you have the definite integral of a rate of change function, you'll get the net change. And we're going to use that when we do part A. Part A is asking how many cubic feet of snow have accumulated on the driveway by 6 a.m. In other words, we know that she's still sleeping until 6 a.m., so she's not removing any snow. So we just want to know, it started snowing since midnight, how much snow has accumulated on her driveway by 6 a.m. So what do we work with? We work with the function f of t that tells us the rate at which snow is accumulating on her driveway in cubic feet per hour. And we know from the fundamental theorem of calculus that the definite integral of a rate of change function will give us the net change. In this case, the total amount of snow that fell onto her driveway measured in cubic feet. So we have the definite integral of this rate of change function from 0 to 6, and we use our graphing calculator to evaluate this definite integral. This is a graphing calculator problem. The only thing is, if you look at the function here, you do have cosine in there. And because of that, you've got to make sure that your calculator is in radian mode. If it's in degree mode, you'll get an incorrect answer here and lose a point. You will get a point for writing this. So another important thing is make sure you write definite integrals. And then use your calculator to write your approximate answer. So that's part A. Let's take a look at part B here. It says, find the rate of change of the volume of snow on the driveway at 8 a.m. In other words, is the amount of snow increasing at 8 a.m. or is it decreasing at 8 a.m.? You've got to remember what's going on at 8 a.m. Because in this sentence, it tells us from midnight to 9 a.m., snow is accumulating on the driveway at a rate modeled by the function f of t. So at 8 a.m., it's still snowing. It is still snowing at 8 a.m. But what else is going on at 8 a.m.? We know it's snowing at 8 a.m., but what else is going on at 8 a.m.? Janet, she's already woken up, and she is starting to remove snow from 6 a.m. until 9 a.m., and we know how fast she's working at 8 a.m. She's working to remove snow at a rate of 108 cubic feet per hour at 8 a.m. So two things are happening at 8 a.m. Snow continues to fall, but Janet is also removing snow from the driveway. So what do we think is going to happen at 8 a.m.? Do we think that Janet is kind of like in a losing battle with the snow, where she's trying to remove snow, but there's more snow that's falling than she's able to remove? Or she's perhaps in a winning battle where she's removing snow, but she's actually making progress because she's able to remove snow from her driveway at a faster rate than it's falling at that time. And that's what this problem is about. Find the rate of change of the volume of snow on the driveway at 8 a.m. So you've got to consider two things. The rate of change of the volume of snow at 8 a.m. is equal to the rate at which snow is falling at 8 a.m. minus the rate at which Janet is removing the snow at 8 a.m. So let V of t represent the volume of snow on the driveway in cubic feet. So the rate of change of the volume of snow on the driveway at 8 a.m. is going to be the rate at which snow is falling on the driveway at 8 a.m. minus the rate at which the snow is being removed from the driveway at 8 a.m. And here's what you need to understand. You've got to understand what f of t is. It tells you the rate. It says here, it tells you the rate at which snow is accumulating on the driveway. So that's actually coming right from there. And you've got to understand what g of t is. It tells you the rate at which snow is being removed from the driveway at a particular time. So g of t is coming from there because we need the rate at which the snow is falling onto the driveway at 8 a.m. minus the rate at which snow is being removed from the driveway at 8 a.m. So you've got to do the rate of change of volume of the snow on the driveway at 8 is equal to the rate at which snow is accumulating on the driveway at 8 minus the rate at which snow is being removed from the driveway at 8. So that's what you've got to do. And you're just going to use your calculator, and you're going to evaluate the function f at time is equal to 8 to find the rate of accumulation of snow on the driveway at 8. And you're going to evaluate the function g at 8 to find the rate at which snow is being removed from the driveway at 8. And you will subtract to find the net rate of accumulation of snow on the driveway, because not only is it snowing, but Janet's actually like removing snow as well. So the net rate of accumulation, or the rate of change of the volume of snow on the driveway, is negative, and that's going to be in cubic feet per hour. So cubic feet per hour there for the units. Because it's negative, that means Janet is making progress. So overall, she's making progress. Although it's snowing, she's able to remove snow at a faster rate than it's falling at that time. Now, part C. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain from 0 to 9. So you've got to read that carefully to understand what h is. H should represent the total amount of snow in cubic feet that she has removed from the driveway at t hours after midnight. So we know the rate at which she's removing snow from the driveway at t hours after midnight. That's given by g of t. But we want to know the total amount. So in other words, we have to take the definite integral of this rate of change function to find the net change. And that's what I've done here. H of t, which tells you the total amount of snow in cubic feet that she has removed, can be found by taking the definite integral of the rate of change function g of t, which tells you the rate at which she is removing the snow. So h of t is equal to, and it's got to be done piecewise. The reason why it has to be done piecewise is because g of t is given piecewise, because they are different rates at which snow is being removed at different times. So, but the idea is you use the fundamental theorem of calculus. The definite integral of a rate of change will give you the net rate of change. So on the time interval from 0 to 6, you'd have the definite integral of 0, the definite integral of 0 from time is equal to 0 to time is equal to t. And you want to use a different variable. You don't want to use t here, so I write dx there. But when you simplify, it's really easy for what's going on between 0 and 6 for time. She's sleeping. She's not doing any removal of snow. So how much snow gets removed from the driveway from 12 to 6? 0. So that's pretty easy. And then what happens at time is equal to 6 a.m.? She wakes up and she starts working. And we know how fast she's able to remove the snow. In that first hour at a rate of 125 cubic feet per hour. But we know that from midnight to 6, she didn't do anything. She was sleeping. And then we have the definite integral of this rate of change will give us the net change. So she begins working at 6, and she's working at a rate of 125 cubic feet per hour. If you evaluate this definite integral, using the fundamental theorem of calculus, this is what you'll be able to get. And you can see that it makes sense because at 6 o'clock, 6 minus 6 will give you 0. 125 times 0 is 0. But if she's been working for an hour, then you'd have t is equal to 7. 7 minus 6 is 1, and she's working at a rate of 125 cubic feet per hour. So after 1 hour of working, she would have removed 125 cubic feet of snow. So what happens at 7? Well, she's already worked for 1 hour. She's already removed 125 cubic feet of snow, and then she continues to work, but not as efficiently. Maybe she's a little bit tired. So she's continuing to work at a rate of removing snow at 108 cubic feet per hour. So the definite integral of a rate of change will give you the net change. But you've got to add that to what she's already accomplished by 7 in the morning. When you evaluate this definite integral using the fundamental theorem of calculus and simplify your answer by factoring, you'll get 108 times t minus 7. And that's for time from 7 to 9. And that makes sense, again, because what happens at 7? Well, she just finished 1 hour, so she's accomplished this much of snow removal. But when t is 7, 7 minus 7 is 0, and all she's done is this much. But when t is 8, she's worked an additional hour after 7 at a slower rate of 108 cubic feet of snow removal per hour. But 8 minus 7 is 1, so you're going to add 128 plus 108 to figure out how much snow she's removed by 8. And at 9, you're going to have 9 minus 7 is 2. She worked for 2 hours, removing snow at the slower rate of 108 cubic feet per hour, times 2 plus 125. So that's how that function works. And it tells you what? It tells you the total amount of snow in cubic feet that she has removed from the driveway, and we get that from taking the definite integral of the rate of change function at which she's removing snow from the driveway, because the definite integral of a rate of change function will give you the net change. Okay, so now let's take a look at part D here. And for part D, we have how many cubic feet of snow are on the driveway at 9 a.m. How many feet of snow, how many cubic feet of snow are on the driveway at 9 a.m.? Well, remember, it starts snowing from midnight until 9. And then Janet starts removing snow at 6 a.m. until 9. So we've got to figure out to answer this problem, to answer this question, how many cubic feet of snow are on the driveway at 9 a.m., we've got to figure out the total amount of snow that fell on the driveway from midnight to 9, and subtract from that the total amount of snow that was removed from the driveway from midnight to 9. So how do we do that? So it's easy enough to find the total amount of snow that accumulated on the driveway from midnight to 9, because again, the definite integral of a rate of change function will give you the net change. So f of t tells you the rate at which snow is accumulating on the driveway from midnight to 9. So you take the definite integral of f of t from 0 to 9, and that will give you the total accumulation of snow from midnight to 9. It's about 367.335 cubic feet. Now, you need to subtract from that the total amount of snow that was removed from the driveway by 9 o'clock. And that's going to be given by taking the definite integral of the rate of change function that tells you the rate at which snow is being removed from the driveway. But we actually did part C, where we found that function, where we found the function h of t that tells us the total amount of snow that has been removed. And we found h of t by taking, of course, the definite integral of g of t on each of those sub-intervals of time and adding to however snow was removed at the beginning of each time period. That's part C that we did earlier. So find h of 9 by using the function from part C, and you would get 341 cubic feet of snow that Janet removed by 9 a.m. So take the amount of snow that fell by 9 a.m. and subtract from that the amount of snow that she removed by 9 a.m. And when you do that, you get 26.335 cubic feet. And notice that I put 3 places after the decimal. That's the general rule on the AP exam. You should have accuracy to 3 places after the decimal. You may have some problems where you're asked to round to the nearest whole number. If that's the case, you would do that, but generally round to 3 places after the decimal. So today we looked at this free response problem in which we are working with functions that represent rates of change.